So what are we going to discuss today, right? So yeah, so as the title says, we are going to discuss about bulletproofing your serverless applications in Google Cloud, right? So like, what does that mean? So basically, like in serverless computing, especially if you talk about Google Cloud, see the same principles applies to all the other cloud as well. So I know that conceptually you could that there'll be an equivalent thing would be there in your AWS or Azure, but predominantly here we are going to cover know what is it that Google Cloud offers, so that you can make your serverless applications more secure than ever, right? So this session we will dive into the strategies to harden your serverless application against threats, and we will also learn how to secure your deployment, manage the identity and access, and how to protect data and monitor the runtime environment. So all this we will cover. So predominantly we'll be exploring all the Google Cloud native tools and the Google Cloud best practices to ensure your serverless workloads are resilient, compliant, and production ready, right? So yeah. So imagine like, you are actually trying to build a digital fortress in the cloud, and as usual, a fortress, it's supposed to be impenetrable, right, to the attackers. But at the same time, the fortress has to be easily accessible to legitimate users, right? So that is what exactly we are going to learn today, and how to do that with your serverless applications, right? So to start with, we need to understand, what is a serverless compute, right? So a serverless basically differs in these three structures. So one is with respect to the operational model, right? So how do they operate? How do they different from your typical virtual machine based stuff? So the operational model is actually different for serverless. So in terms of operational model, there is no infra for you to manage, right? Obviously, there'll be servers behind the scenes which Google or other cloud providers will manage and things like that. But there is no infra that the customer has to manage, right? So you take your application, you run your application, and then you secure your applications on a particular layer, and then we are safe there, right? So the operational model in terms of is no infra management. And then it also provides a fully managed security. So when you say fully managed security, like, they take care of even including the platform level, they take care of the security, and only the application security is our concern, right? We don't have to worry about whether the VMs are patched. We don't have to worry about whether the latest attack is going to affect your applications and things like that, because those things will be taken care by the cloud provider itself. And then only the application related security, right? So only that will be the concern of the customers, right? So in terms of operational model, these two are the major differences. And when it comes to the programming model, so predominantly a serverless application supports service-based, which is like your typical REST-based applications and things like that. And it is very much suitable for stateless application. Although there are current releases that happens, which predominantly support stateful applications as well, but it's still in sort of I wouldn't say like I've never seen it to be used in a larger scale, like where a serverless being used for a stateful applications, but it's predominantly used for a stateless application. And the third major factor is the economic model. So how are you going to pay for the services, right? So here in case of serverless model, you are only going to pay for what your customers are going to consume, right? So let's say if you're you are exposing an API and somebody is calling your API for 5 times, right? So the number of seconds that you are running for those 5 APIs, so that is what you'll be paying for, and there won't be any cost other than that, right? I mean, there are other configurations where you can keep it running 24/7, but then the predominantly it will be pay per the usage, right? So only when, like, if you take scenarios like things could scale up rapidly during the Diwali days, and after that the traffic will be less. So during Diwali days you might have to pay higher, but on all the other days that you'll be charged on a lower rate only, right? So that is the beauty of the serverless compute's economic model. So yeah, going to that. Okay, so now coming to the actual topic that we are going to discuss today. The first thing that we are going to talk about a list of network security controls that we are going to have. So think of network security like securing your corporate office building, right? So you need to control who enters, which is what we call that as ingress in technical terms, and what your employees can access from inside, right? So that we call that as an egress. And then we need to have security guards at the entrances. So that is what the Cloud Armor is supposed to do for us. And then you will also have different security zones within your building itself, right? Like, for example, some part of your building will be called as an administrative office, where not all people will have access and things like that, right? So similar thing, we can do it. So VPC Service Control is the one that is going to help us to do that, right? So I mean, that's a short intro for all this. Let's see how this translates to the serverless that we're going to see. Okay. Now, so every application, be it serverless or not, right? So it needs some way for you to access. So in Google Cloud, so what happens is when you deploy something serverless, so Google is gonna front end it automatically. Like it will have, there's something called Google front end, which is nothing like the load balancer, right? It will front end your traffic. And then when a request hits the traffic, it is going to distribute the traffic across to your serverless applications, right? So you might be running a single service or multiple service, and you can also give a scaling factor, right? How you want to scale it? Like, do you want to constrain the minimum, maximum, and all that stuff? But then, so what Google does is like it gives you a typical domain. So in this case, it could be .run.app for Cloud Run, a product within Google Cloud which offers the serverless compute, right? So for the .run.app, if any request comes in, so the Google Cloud frontend will actually distribute the load across to your existing wherever you got your application deployed. Right? So yeah. And the Google Cloud frontend also manages all this rollbacks, gradual rollout, and you can even do advanced thing like traffic migrations, right? You have a version 1 of your software that is running in Cloud Run, and you want to deploy version 2, but you want to only split like 20% of traffic to the version 2, and the remaining 80% to still happens to the version 1, right? So if you want to do that, all that you can do in Cloud Run, right? So this will be out of our discussions, but yeah, these are some of the cool features that Cloud Run and Cloud Functions actually provide, right? All right. So now coming back to our Ingress and Egress. So yeah, as I said, anything that is going to hit your applications, so the technical term that we call that Ingress. So be it Cloud Run or Cloud Functions, any request that comes in, that is actually an Ingress. And anything that goes out from your application to the external world, that is actually called Egress. Now, in case of Ingress, so Google Cloud protects. There are 3 different settings that you can actually do. But what generally happens is before your services, Google Cloud will be running something called the Ingress proxy. And what the proxy does is it actually filters requests based on the origin, right? Origin of the request. So if the request is originated from within your VPC network, or if the request is originated within the load balancer, right? Or from other resources like internet, or you can even integrate Cloud Run with other services like cloud storage, PubSub, EventArc, and things like that, right? So those categories would be there. So based on the origin of the request, you will be able to control whether your service has to be accessible or not. Yeah, thank you. So typically there'll be 3 settings that is there, right? So one is allow all traffic. So this is the default, right? So unless you set it explicitly to something else, so this will be the default whenever you deploy Cloud Run, things like that. So by default, it is allow all traffic. So whether from external world or both from the internet, also from the other Google Cloud services like Cloud Scheduler, EventArc, and things like that, it will be allowing the traffic to your application. So, and the next step is allow internal traffic, right? So this prevents any request from the external world, right? So no external applications will be able to reach you. And even within your VPCs, like let's say you have another Cloud Run, from which you want to call this Cloud Run, right? So which will be allowed again. And then you also have EventArc or the PubSub or BigQuery, which is all in the same project as where you deploy the Cloud Run. So that will also be allowed with the allow internal traffic. And any traffic that originates from your VPC, you can simply have one more virtual machine in the same VPC, and the VM will be able to access your application, right? So that is the allow internal traffic. And the last is basically you allow from the internal as well as from the load balancer, right? So this is what typically recommended for any public facing applications. So usually, like, we don't want to expose our applications without coming through our domain, right? So if you look at my other slide, so here you can see, by default, when you deploy something in the Cloud Run, it actually gives its own HTTPS URL, right? Something like app1.run.app, right? Which is not even your actual domain. So there are provisions to map your custom domains, and you can also map a load balancer in front of it and then have the traffic. We will see that in the further down, right? So yeah, so typically, when we have a public exposed applications, we don't want to expose it through our run.dat application. So the recommended settings to go for your Ingress is to allow internal traffic from Google Cloud Load Balancing. So this will make sure your internal traffic is covered, plus the external traffic via your domain will also be covered through this sort of setting. Right. Yeah, so this is the typical example demonstrating, like, when we set, when you disable the Cloud Run default URL, which is a security best practices. So the moment you disable it, your own VPC network will still be able to access your service through the default URL. But any user from the external, they won't be able to come in through the default URL, right? So, that's a typical method to go for. And the traffic will also be allowed from your HTTPS load balancer also, which is what we want all our customers to come in from, right? Yeah, so that's the way the Ingress actually works. And we'll talk about load balancer in the next session in detail. So I know, like, we have been touching upon this, but I think it is coming next. Okay. So yeah, so we talked about Ingress, right? So what about Egress, and why should we concern about Egress? So that is the other question that everybody has, right? So the main reason that you have to be concerned about Egress is you need to know if somehow your application is accessing something which is a third party, but it is not supposed to do, right? So maybe it is accessing your competitor's thing, right? So which is you are not supposed to do, or it is doing something malicious, right? For example, it is posting details to another third party, which is not supposed to do, right? So all that security gaps are there. So that is why it is always necessary to control or monitor what actually goes on the egress also, right? So Google Cloud in the serverless environment, right? So it supports two things. One is the serverless VPC access, so which actually deploys a connector in between. So all your outbound requests from your service, it will actually go to the connector, and then from the connector, depending upon what policies that you set and things like that, it will be forwarded back, right? So, and this is the default mode till 2024, till I think May or April 2024. But then after that, they recently introduced something called a direct VPC access also. So through which the Cloud Run can directly access things at your VPC. Now, so the egress, right? So we can categorize into two different things. One is your application that is maybe a backend application that is running in Cloud Run. It actually needs to connect to your SQL Server or cloud storage, right? Or a Redis database or a memory store database and things like that. So it has to connect to the backend. So how does it connect? Because the Cloud Run is serverless, it doesn't run within your own compute environment, right? It runs somewhere where Google has hosted it and things like that. So for that to come in and access, so that is where the VPC connector or the direct VPC egress comes into picture. So all your requests will be forwarded to the VPC connector, and through the VPC connector, you'll be able to access your Cloud SQL, memory store, or if you are having some services running in Compute Engine, which your serverless application need access. So everything is possible through this, right? So that is your that is the way to access your actual database and things like that from your application. Right. So yeah, so in the egress also there are two settings to control. So typically, like, depending upon your requirement, one is private ranges, so which means if the cloud run, the service that you're running in the Cloud Run needs access only to the SQL database, memory store, or the compute engine, which are all private, right? Only that will be routed through this VPC connector. And the other set, like, but if it is sending a request to, let's say, third-party APIs and things like that, that will not be routed to your network, right? So that is the first setting. And the second setting is all requests, right? So in case of all requests, what happens is, no matter whether you are accessing an internal VPC Cloud SQL, or you are accessing, let's say, Google or a Cloud API or a third-party APIs, right? So all that traffic will be coming through your VPC connector, and it comes into your VPC. and then all your DNS rules and all the firewall rules that you have for your own VPC, everything will be applied for that, and then only your traffic will leave to the external world, right? So if you really wanted to monitor what happens, what is the egress traffic that your cloud is actually sending, so it is always recommended to set it for all, and all your traffic will come through your VPCs, and all the DNS resolutions, all the firewall rules that you have within your VPC will be applied for the outbound request as well. So yeah, there are a couple of useful examples where we actually need to set it to all, right? So one is if you've done any sort of a payment gateway integrations or any third-party integrations, right? So typically they will ask you, can you give us a set of IP address so that we will whitelist, right? So that's a common use case. So they will say that if I have a payment gateway integrations with some third party, they will ask me, okay, tell me from what are all the IP address you are going to send request to our IPS so that we will whitelist at their end, right? But being a serverless environment, what happens is, like, if we don't have this way of coming through the egress to the VPC, by default, what will happen? Every time the third party is going to receive a request, it is going to receive a request from a different IP address, because that is how the Google actually scales, and the Cloud instances will have different IP addresses. But in scenarios like this, we actually wanted to have a static outbound IP, right? So which is typically implemented with a feature called Cloud NAT. And so what we will do is we'll set the egress traffic to all and make sure all the traffic comes to our VPC. Then in the VPC, we will have a NAT gateway with a single or multiple static IP addresses. Then that NAT gateway IP only will be seen by your third party. So this is a very good use case where you have to route, whether you want to monitor or not, but you still need to route the request to your VPC. And the other example would be for you to prevent outbound traffic to any dangerous or unwanted host within your network firewall rules, right? So that's given. So these two cases where you have to switch it to all, and then make sure you route all the requests to your VPC. All right. So now coming to the load balancer part. Okay, so typically what is a load balancer? So it is basically a single anycast IP, right? So it is from anywhere in the world, and Google actually provides a different sort of load balancers. So here we're going to talk about the global HTTP load balancer. So it will give you single IP addresses, and you can have your application. Let's say if you're really into DR, or you want to make sure even if a single region is down, your application is still available from other regions and things like that. You can deploy your serverless application in multiple regions, right? But how are you going to serve those requests, right? So that is where the single unicast, anycast IP address comes in. So the load balancer will have only one IP, but no matter in which region you have deployed your Cloud Run services, so the load balancer will be able to route the request to both of them, or depending upon how we are going to set your the load balancer rules, right? So it supports host and path-based routing. So you'll be able to say, okay, /app, go to this service, /app2, go to this service, /backend, go to that service, right? So all that we'll be able to do it when we have a load balancer in place. And the third thing is, it actually, the load balancer provides integration with three more very important services for any applications. One is Identity-Aware Proxy. We will see what is that later. And another one is Cloud Armor, and we'll see that in the next slide. Then you have a Cloud CDN, right? So Cloud CDN is where like all your applications, if you want to cache the images or all your JavaScript, so all the caching happens on the CDN layer. So with the help of a load balancer, you will be able to have a CDN in front of your applications. So all your static resources and things like that will be served from the CDN itself without hitting your services. Thereby, you will also save on the network cost as well, right? Because it is not being served from your applications every time, right? Only when there's a catch miss, your application is going to serve those. But most of the times it will be catch hit if it is a frequently used stuff. So it will actually use the CDN part of it. So now coming to the Cloud Armor. So Cloud Armor is basically sits along with the load balancer, and it helps to mitigate distributed denial service attacks, right? So if I believe most of you are aware of what is distributed denial of service, right? So it's basically like, let's say you're getting popular and nobody likes you. So they actually send a lot of requests to your service. So two things going to happen: either you are not able to gonna scale up as fast as the requests are coming in. In that case, your service will be down for the legitimate user, right? Or even if you're able to scale up massively, you're going to incur charge because, like, a lot of people are hitting you. So in a serverless environment, you're going to scale quickly. And if you scale too much, and each of those scaling is going to attribute as a cost, but those are not the real customers, right? So I mean, that's a simple way to put what a distributed denial of service attacks are, right? So this cloud armor helps you to protect your application from the distributed denial of services. That is one. And okay, so the DDoS happens mostly on layer 3 and layer 4, right? And you can also control with the help of Cloud Armor to allow or block IP based on, to allow or block traffic based on IP addresses. Like I said, let's say if you are the third party, you are implementing, and you want to whitelist the traffic only from certain IP addresses, right? So that is also possible with the help of Cloud Armor. And you can also say based on the geography where the user is coming from, right? So for example, let's say if you are doing a quick service restaurant in India, and you don't need, I mean, the customers are not going to order from your application from US, Europe, and things like that. All you need is the traffic from India only, right? So based on the geography, you'll be able to say, okay, allow all the requests if it is originating only from India in the Cloud Armor, right? So thereby, all the unwanted traffic, be it from China, US, UK, or any of other countries, right, we'll be able to block those traffic because that is what your application actually needs, right? So this differs based on application to application, but mostly it comes in handy if you are only serving a particular country or a particular region, and you definitely don't need traffic from the across the world, right? And you can also do some custom match parameters, like if your load balancer is in front of it, and then you can say, okay, accept traffic only from the load balancer. The other important thing that Cloud Armor does for us is it defends our application against what we call that as a OWASP attacks, right? So open web application security attacks, right? All those. So that, like, if you heard about these terms like cross-site scripting, SQL injection, all these are application layer attacks. Okay, remember this. So the DDoS is actually a network layer attack. So mostly Google will detect it, and then they will be able to respond. But all this SQL injection, cross-site scripting, and all the other attacks, right? So these are all originate on the application layer. Okay, so based upon how you handle the inputs to your application, if you're not doing the SQL injection checks properly and things like that, your application will be vulnerable, and the Cloud Armor will be able to protect you, right? Even if you have not done a proper validation and things like that, but if Cloud Armor sits in front of your application, it will protect your application from all these different types of attacks. So by default, it protects you against the top 10 OWASP attacks. But if you need additional and things like that, you will be able to configure it, and then you'll be able to save your application from that also. So typically we see customers, right, like what they do is they run VPT for their applications, and then they come up with a list of recommendations, and most of them would be this OWASP attacks only, right? So then based on the rules, based on what the VPT result says, like we'll be able to configure them with the Cloud Armor and things like that. Right. And the last thing is the telemetry. So it is again, telemetry is very important so that you know what Cloud Armor is actually doing. Let's say a legitimate user is complaining that, hey, I'm trying to order something, but then the order is not going through, right? So there could be multiple points, like where we have Cloud load balancer first, and then we have Cloud Armor. We don't know if Cloud Armor is blocking the request or not, right? So we need to have the telemetry for that. So the Cloud Armor has to say, hey, these are the traffic that I blocked and all that. So all that is integrated into the Google Cloud login. So in a single place, you'll be able to see all those information, so which will save a lot of debugging time, right? So that's about the Cloud Armor. Yeah, so this is, so when we have to write a custom policy, right, like I said, if you need to write your own policy for the Cloud Armor and things like that, so what we typically do is we actually create a policy and then attach it to your Cloud Run services, right? So here the way that request comes is like, you have the load balancer only. From the load balancer, it comes to the URL map service. The URL map will say, if it is /app1, it has to go to the Cloud Run app1, and if it is /app2, it has to go to the app2, right? So this is the host and path-based routing that we can configure in our load balancer. And the Armor policy will be attached directly to the backend services. So when any request comes to the backend, So it will be validated for all the different types of attacks that we talked earlier, and your applications will be protected from all of that. Okay. So yeah, so then comes the VPC service control. So this is like I said, if you want to allow, but allow the traffic, but at the same time you also want to prevent, like, so typically, right, in a typical hybrid world where you are actually doing work from home, right? So what VPC service control does for us is, if you are present in the office or within VPN, right, within the office VPN, you will have access to certain resources. For example, you'll be able to download something from the cloud bucket, or you'll be able to access a critical cloud run services, etc. Right? That is one set of a VPC service control. So if you are outside, you will be able to maybe read it, but you will not be able to download it. Okay, so let's say if you are going to a cafe and then you are logging in without the VPN, you are trying to access, you might still have viewer permission, but not the download permission. So you can view it, but you won't be able to download it. So these sorts of perimeters we can actually define with the help of VPC service control, right? So obviously, like, this actually comes the last part. I will actually go through the list of priorities and how we should actually see things. But usually this comes at the last part, but it's a very critical part if you are an enterprise and then you want to handle these sorts of requirements. Right. So yeah, so the next thing we are coming into the access control. So the access control happens through Cloud IAM rules. So I think all cloud are more or less similar in this respect. So you have something called an identity, which actually defines who, and you also know what that identity is going to do and on what resource, right? So that's typically what an IAM does. So in case of this cloud run, so there are Google Cloud supports multiple roles, and based on the requirement, the always recommended pattern is to assign the principle of least privilege, right? Whatever the service needs or whatever the user needs, only that you should be assigning it. If they need anything further, you will assign it only at that point in time, right? So there is no point in giving somebody owner access, even though he actually only needs a viewer access, right? So that's the same way. So you only give an access of what is actually required. So we will be doing it with the help of the IAM rules within Google Cloud. And Google Cloud also has something called inheritance, right? So for example, if you give access at a higher level, so that access will be inherited in the lower level. So even if the lower level, if you don't give the access, the users still have access at the higher level. So it is usually recommended to for the super administrator and things like that to have access at the higher level. But at the lower level, you should be accessing for your developers, testers, and things like that. They should be given access at the lowest level, right? So the inheritance is not taken for granted. Right. Yeah. So this is the typical flow of how service invocation works, right? So when a client requests, so it actually first comes to the IAM, and the IAM verifies if the request is authorized or not with the help of IAM policy. If the user doesn't have the required permissions, then it will reject the request automatically. And if the user already has the permission, it is going to allow. So this is the typical flow of what happens, whether it is cloud run, cloud functions, or be it for any other services. So this is going to stay the same. But since we are talking about cloud run and cloud functions, so this is how the request carries through. Right. So on top of it, so there might be cases where we want our users to have access to public, right? So in that case, so there is a special user type. It's called all users, right? So if your service generally needs public access, for example, if you're deploying a front end, obviously the front end will need public user access. So then you can actually give the permission for all users, so anybody will be able to access your applications, right? So this is as if like you are making sure anyone can deploy. I mean, sorry, anyone can access your applications, but you secure your backend. I have a demo at the end where I will show you how the front end and backend communicates. Right? We'll see that shortly. Right. Okay. Yeah. So IAP is one of very interesting feature, and I've seen very few people actually use it as it is intended. Right. So what IAP does is it actually sits with the load balancer, right, along with the load balancer, and when a request comes in, it first validates. So it is actually like having a sign-in page or having an authentication page in front of your application, even though you haven't implemented it. So what will happen is you will see a Google sign-in button, and only if you sign in with your Google and whatever the ID that you're signing in has the permission to access the particular application, you will be allowed to access the application, right? So I've seen we have actually implemented this for a few customers where they have their beta application, right? I mean, you have your actual live applications and you also do a beta applications or the QA applications, right? So though they want that to be public because they follow a remote culture, but they want to prevent. So something like, preprod.domain.com, right? If somebody accesses that, they'll be able to see what is the new feature, the beta application they are doing and things like that, right? And obviously they don't want their competitors to see that. So and they don't have a lot of time also to invest and then do all the other security measures. So what we simply did is we actually leveraged the Identity-Aware Proxy. We put it in front of it. So only if users log in with the customer's domain, right, they'll be able to see the application itself, right? So if anybody else, even though the URL is accessed publicly, but if anybody else sees that, they won't be able to access the application. So that's a very, very, very good use case of having an IAP in front of your applications. Right. Okay. So now, so we've discussed about network. We also discussed about how using identity, different layers of identity, we'll be able to secure our applications. So then the third thing comes to the service-to-service communication, right? So how, like, let's say if you have two Cloud Run service account, and how if you're going to call one is front end and another is back end, if the front end is calling back end, how it is going to authenticate, how it is going to securely authenticate, and all that question comes in, right? So we are going to cover that in this part. Right. So the first thing is in Google Cloud, right? With Cloud Run, by default, it actually uses something called a service account. So the way to remember what the service account is, basically it's a robot account. Okay, so like we as a user has an account and a password, so we type it and then we log in. But how do services, programs authenticate to other programs, right? So that is with the help of service account in Google Cloud. We call that a service account in Google Cloud. So by default, there is something called the compute engine default service account, which will be used by the Cloud Run, which is actually not a recommended best practices. So the first thing that you have to do is you have to create a service-specific service account for each of the Cloud Run. So even if you have 5 different applications, each are deploying in a separate Cloud Run, all the 5 should have 5 different identity, right? So it has to identify user A, user B, user C, and user 5, right? So 5 different service account has to be there. And then you assign each of that identity what permissions they would be needing, right? For example, one would be needing write access to your storage bucket. Another will be needing only read access to the storage bucket. So you need to make sure then the service account 1 has write access and service account 2 has read access, right? So this way, if you set it to the minimum, so a lot of unavoidable consequences like the reader is actually writing and all that will be avoided if you follow the principle of least privilege. Right. And yeah, so typically when we invoke different services, so the flow happens like, from the service account, depending upon what you are trying to access. So it goes and then it authenticates a request. And if you have the Cloud Run invoker role, then only, it will be allowing you to invoke the particular Cloud Run. So it could be a service account, or it could also be other services like PubSub subscriptions, Cloud Run service. I mean, this is what we are talking about, and workflows. And you also have cloud tasks and things like that, right? So think of cloud tasks like, you have multiple tasks in queues, and whenever something is added into the queue, it is going to call a particular Cloud Run service to handle that queue, right? So now Cloud Task Queue itself is a service, and it is going to access the Cloud Run. So it has to authenticate, and the authentication happens via the service account. Right. So okay, so there'll be other questions. So like we have seen how a different Google Cloud service can actually access another service with the help of service account, right? And the same thing, even within your own code, right? Like you have a front end code, and you want to call an API, but the API is actually protected, right? So then you have to authenticate to that API. So if you want to do that within your code also, so there are API libraries that are available in Google Cloud for all the different sort of languages, Java, Python, Node.js, etc., etc. So by leveraging that, you'll be able to get a token, and using that authorization token, you'll be calling the other services, and the other services will validate the token, and then it will let you access the particular application. So I'll show you an example shortly on that. So yeah, this is an example of how you should use. It's in Node.js, but yeah, so we do have it in Python or all the other examples. So this is the general way. If from your code, if you want to call a service which is actually protected through IAM, so then this is the best practice to follow to authenticate to the other service and then access the service. So what happens behind the scene is this. So you have your one second. This one. Yeah, thank you. Yeah, so we have a Cloud Run where our code is running, and it is trying to invoke another Cloud Run service. Okay, so now what our code does is it actually uses the client library, and using the client library, it identifies for its own service account, it identifies their token. Then using that token, it will invoke the other Cloud Run. Now this Cloud Run, it knows that the token is there in the header. So then it actually parses the token, checks if the token is valid, and it is from this particular service account, and whether it has this particular role, all the checks it does. And if all are satisfied, then it will allow the service to call this service, and then the request and response happens, right? So that's the flow that happens between service to service communications. Yeah. So the other important aspect is how are you going to manage secrets? So typically when people start to deploy things and things like that, like especially in front end or be it in back end, they store their secrets within their own environmental variables. Like they create a .env file, or they create a config file, and all the database usernames, passwords, and things like that are stored within the container image itself, right? So which is actually not a best practices to do. And the easier and better way to do that is to start using Secret Manager. So the moment you use Secret Manager, so Google Cloud allows you to do two things. One is each secret, you can expose it as an environmental variable dynamically, right? So which means only if your application has access to the secret, you'll be able to see the secret, right? So that way. The other way is to mount it as a volume, so that you can read it as if you're reading from your local file system. So these two are different ways to access, but it is actually 100% recommended to use Secret Manager to store all your secrets rather than storing it in within the container itself, things like that. You can also leverage other third-party tools like HashiCorp, Vault, and things like that. But yeah, but it is not recommended to store things in GitHub repos or within your own container platform, etc. Right? All right. Now, let me quickly show which happens. So let me just show you my Google Cloud console. Yeah, here. All right. So I have actually two applications, right? One is called Editor, and another one is called Renderer, right? So let me open up the editor for you. Right. So Editor is actually a front-end service, right? So typically, if you see, I'm going to access it directly using this Render tab, for example. Yeah, once I access, I'm seeing the editor, the UI is all coming down. And if I type something in a markdown format, it is going to convert it into an HTML format for me, right? So that is what's happening. So let's try by removing this and then preview. You can see that whatever I removed, it has actually got removed over here, right? So these are simple applications where the editor is actually the front end. And when we do something, and then if you click on the button, so it is actually calling the backend service. And then the backend service is doing the markdown to HTML conversion, and then it is updating the UI, right? So this is what happens behind the scene. But let's see the parameters that we want to see, right? So yeah. So if you see this particular service, it is right now open to all, okay? Because we want the service to be public, and we want all the users to be able to, click on this URL and then able to access our renderer service. And you can also see that I passed the environmental variable, and which is actually the URL for my backend services, okay? Now, if you see the security tab, you can see that this particular service, I've used a separate service account called editor-identity, right? Because like I said, every service should have its own identity, right? So this editor service has its own identity. Now, if you come back and then see our rendered service, right? And if you go to security, yeah. So you can see that the first thing is it is requiring an authentication, right? It is not publicly allowed. So this backend is, needs people to have IAM permissions to be able to access. So then naturally the question comes, how come the front end is able to access the backend, right? So because right now if you copy this URL and let me paste it once again, I'll share this tab. Yeah. So right now, if I access this particular, which is the backend applications, so I'm going to get the error, right, for forbidden, because I haven't really authenticated with anything. So because it's a simple browser client I'm using, and there is no authorization header or whatever. So when I use this, so it's going to say that it is forbidden. But how come the front end is able to access the backend? That is because of the code that we have written, right? So what the code does internally is actually, if you see this part, yeah. So you can see that it is actually calling and the Google Cloud library to fetch the identity token like we saw in the service to service communication, right? Just these two simple lines, right? Nothing fancy, right? Just these two lines. So first line is going to get your identity token. And then the second line is going to add a HTTP header saying authorization and then attach the token to this. So once these two is there, then when you request the backend, now the Cloud Run will check for this token. It will know which service account and whether the service account has access. So based on all that, it is going to allow it, and then it will have the appropriate access, right? But at the same time, if any unintended users they are trying to access, you'll be because you don't have a valid token or valid service account and things like that, you'll be getting forbidden messages, right? Yeah. So and this application is open. I will try to share the URL. Yeah, if you, I mean, there is a whole lot of applications, but I just chose this because we have a front end and back end, and we can demonstrate, how the communication happens between service to service. Okay, 1 second. It's fine. Yeah. So coming to this, okay. Yeah, I think we are almost time. Yeah. So what are the key action plans? Okay, all this we have discussed, but I see that there should be some takeaways, some action plans, so that if you are really interested in deploying things into serverless, what are the immediate things that you can do, and what are the things that you can take some time and then do and things like that, right? So first is you need to remove the default service account, right? Do not use the default service account because by default it has a higher editor permissions and things like that. So it is not really recommended to have a default service account. And this is very easy to implement also, right? Then second thing is set your ingress controls so that you don't allow, especially for your backend applications, right? So you don't allow direct access to all your backend applications, only have access to the internal and cloud load balancing. And the third is to enable audit logging in your Google Cloud so that you know what people are doing and what service is accessing what service, etc. And definitely implement per service identities, right? So if you have 5 different services or 8 different services, make sure each of them has separate identities for them, right? So that is the immediate steps that you can take, and it's not going to take you more than 1 to 2 hours for you to do all this. And by this itself, you'll be having around 50 to 60% of your security footprint, right? So that will be covered over here. Then the next thing what you can do is implement your IAM roles with least privilege, right? And if you're having some secrets, move the secrets into secret manager. That will be the second. And you can also set up your VPC connectivity. So all your accesses, including your external access and things when it comes to your VPC, so that all the firewall rules and everything else applies for whatever the outbound request also. So that is the next you can do. And make sure you configure your resources and limits, like how much memory, what is the concurrency that you want to handle, and all that. That will help you to keep the cost in control in terms of any security incident as well. And then comes the next set of it, which is to deploy a load balancer in front of your applications with Cloud Armor, right? Because this Cloud Armor is going to bring in you a lot of value in terms of protecting your applications from all the vulnerability attacks, all the application layer vulnerability attacks and things like that, right? So it's going to add a lot of value there. You can also implement something called a binary authorization. So this is like mostly like typically in a cloud run environment, any container image you'll be able to deploy it, right? So you can even take a public cloud run public container image and then deploy it as part of your cloud run services. So sometimes some enterprises will see that as a security risk, because what if a public container image has some issues, and then if the developers are actually deploying the public image, right? So they have a process where the container image building itself has go through a larger process where there'll be a security team involved, and they will actually say what to go in and things like that, right? So those image will be saved, and then it will be attested by your security team. And in Cloud Run, you'll be implementing binary authorization. So no other images you'll be able to deploy. Only the images that is signed by your security team, you'll be able to deploy it, right? So that is that keeps it more secure, but then you also need all the other processes also in place for that. Then, then obviously the next thing is to enable your container vulnerability scanning, right? So make sure you scan your images regularly to detect any security vulnerabilities. And you can also set up a security command center in Google Cloud to monitor any of the attacks and alerts and things like that. Yeah. And at the last, try to establish a VPC service control perimeter. So this is going to prevent, like, for example, if you want to have a better control in terms of if the users are authorized, but if they are coming in from a public network, then you want to give them a least access. But if they're within their VPN, or if they're within Office, they're trying to access, then you want them to have a better access, right? So all that you can implement with the help of VPC service control. And you can also automate the incident response for your team for any security incident and things like that with the help of security command center. So this will be the last thing that we can do. And so coming to, yeah, right. I think we are almost end of it. So, and please do remember, there's nothing called a perfect security, right? But a better security is definitely achievable. So every year, every layer that you add, every control that you implement, it will make you a less attractive target, and the attacker will try to generally move on to an easier target, right? So yeah, so that's about it. Thank you for joining today. And yeah, your serverless applications don't have to be vulnerable. So with the patterns that we discussed, they can truly be your bulletproof, right? You can truly bulletproof your serverless applications. And I hope the session actually was useful, and you are able to learn something around the how to secure your serverless applications and how actually Cloud Run works and all, right? Yeah. So we are actually planning to conduct a lot of other webinars in the coming months. So your support will be highly appreciated. Yeah. Thank you. Thank you, everyone.